exam paper. I'm going to share my screen and I'm going to start going through the questions one by one. You can go through the ones that you know that you got wrong or the ones that you know you struggled with. If it's all of them, great, go through all of them. Okay, I'm doing this so that you can watch it at your own time. You can stick to the ones that you know you did wrong. And then it gives you the chance to actually focus on it a little bit. Okay, so question 1. First thing is, please remember you can highlight your question. So have a highlighter, even a pencil just to underline important words so you know what you're looking for. So question 1, in which changes do the particles move further apart? So in your head, you need to be thinking, okay, further apart would be like this, whereas close together would be like this. Okay, I'm trying to get it close as possible. Okay, close together, obviously they would be touching. I can't quite get that. Okay, then you need to think, okay, well, this must be a gas, this must be a solid. So if I want to go further apart, I need to go from a solid to a gas. Okay, if you look at the top line, W and X, W is going from a gas to a liquid. You are condensing. Okay, your particles are getting closer together. X is going from a liquid to a solid. Again, you're getting closer together. So if we look at this bottom line, if we're going from a solid to a liquid, they're moving slightly further apart. And if we're going from a liquid to a gas, they're moving even further apart. Okay, so that is why your answer is D. Y and Z. You can see that the arrow is going this way. Okay, so it's going to the right, to the left. That is Y and Z. Your particles are moving further apart. Okay. Question 2, in the chromatography experiment shown, which label represents what? The solvent front. Okay, the solvent front is how far the solvent moves up the paper. So your answer is not C because that's just the solvent. D is the start line. A is the solvent front. That is how far the solvent moved up the paper to carry your dot. Okay, so question 2, your answer is A. Okay, question 3. One of the instructions for an experiment reads as follows. Quickly add 50 centimeters cubed of acid. Okay, so what are they caring about? They're caring about speed, not necessarily accuracy. So which is the best piece of apparatus to use? It's going to be a measuring cylinder. Okay, the reason is a burette takes a while because it drips. A pipette takes a while. Yes, it's a lot more accurate, but they're not asking you for accuracy. They're asking you for speed. How do I quickly add 50 centimeters cubed? Measuring cylinder, 50 centimeters cubed, add it in. Okay, a burette takes time. A pipette takes time. They wanted to know quickly. Okay, question 4. 2 statements about diamond are given. Diamond has a giant 3-dimensional covalent structure of carbon atoms. That is correct. Remember, your diamond looks like this. Okay, 4 carbon atoms joined to each other. Okay, I'm not going to draw it because it takes too long. Okay, but you've got 4 carbon atoms all joined to each other, and it is a giant structure, and it is covalently bonded. Okay, diamond is one of the hardest substances known. That is also correct, and that you just have to learn. So which is correct? Both statements are correct, and statement 1 explains statement 2. That is correct. The reason that it is so hard is because it's a giant covalent structure. That's what makes it hard. Okay, so statement 1 does explain statement 2. Okay, so your answer there was A. Right, question 4. The diagram shows a cup of tea. Which row describes the water particles in the air above the cup compared with the water particles in the cup. Okay, so above the cup, we have a gas. Okay, this is gas. Water in the cup, hopefully you know, is liquid. Okay, so we are asking you, what is the difference between a gas and a liquid? Okay, so which row describes the water particles in the air above the cup? They are moving faster, yes. I'm just checking my answer. But they are not closer together. It's a gas. Okay, so A is wrong. They're moving faster, yes, it's a gas. They are not closer together. Yes, that is correct. Your answer is B. Okay, question 6. Which row shows the changes that take place when an element X gains the new particle shown? Okay, so you got to bring in a bunch of information here. What is the particle? Electron, proton. What happens to an element when it gains an electron? Okay, so straight away you should be thinking, okay, if an element gains an electron, it's going to become negative. It's gaining a negative electron. Okay, if an element gains a proton, what is happening? It's actually a new element. Remember, if you change your proton number, you change your element completely. Carbon has 12 protons. If I get 13 protons, I'm no longer carbon. Okay, so that is how you should look at this question, and now we go through the answers. So A, if you gain an electron, an isotope is formed. Wrong. Okay, if you gain an electron, you form a negative ion. Electron. Answer B. If you gain an electron, the element one place to the right is formed. Again, that is wrong. If I gain an electron, all I do is change my charge. Okay? If I gain a proton, an isotope is formed. No. Okay, an isotope is formed when your nucleon number changes. Okay? So that leaves us with D. If I gain a proton, the element one place to the right of X is formed. That is correct. I have carbon 12. If I gain one more proton, that makes me 13 protons. That means I move to the right in my periodic table. Okay, so this one had to require some thought, and you had to figure out, what am I forming when I gain an electron? What am I forming when I gain a proton? Okay, question 7. The symbols of two atoms may be written as shown. Which statement about these atoms is correct? So what you need to do is go and find these numbers, remembering that the smaller number is your proton number in both of them. So X has 23 protons, Y has 24 protons. This is the nucleon number, protons plus, okay, I can't do a plus, protons plus neutrons. Okay, so which statement is correct? They are different elements, so that is correct, but the reason is wrong because they have different numbers of neutrons. No, they are different elements because they have different numbers of protons. Okay, so the reason is correct. They are different elements, but the reason is wrong. The statement is correct. They are different elements. The reason is wrong. It's not because they have different numbers of neutrons. It's because they have different numbers of protons. And you will see that's B. They are different elements because they have different numbers of protons. That is correct. Proton number is what makes an element. If you have a different proton number, you are a different element. X has 23 protons, Y has 24. Okay. C, they are isotopes of the same element because they have the same nucleon number. Wrong. You're only the same element if you have the same proton number. They are isotopes of the same element because they have the same proton number. Again, that's wrong. They don't have the same proton number. X has 23, Y has 24. Okay, so your answer for number 7, B. Right, number 8. The diagram shows how muddy water can be purified. Which process for purifying the muddy water is shown? Okay, this is easy filtration. Okay, you're filtering the water through the sand, the gravel, and the small pebbles. It's not crystallization, that's when you leave something to form crystals. Certainly not distillation, that's when you boil it. Solvent extraction, who even knows what that is? Okay, so your answer for number 8 was C. Okay, number 9, I've put a star next to it. Again, a couple of people got number 9 wrong. Which statement explains why isotopes of an element, so we're looking at isotopes, why they have the same chemical properties? Okay, for this one, you need to remember that what gives an element its chemical properties is its outer shell electrons. Okay, so they have different numbers of neutrons. That is correct. Isotopes do have different numbers of neutrons, but that's not what gives them the same chemical properties. Okay, they have the same number of electrons as protons. That's not necessarily true. Okay, you could have a charged isotope. You could have 3-. Okay, they have the same number of electrons in the outer shell. That is correct. That is what gives it its chemical properties. D is a correct statement. They do have the same number of protons, but again, that's not what gives them their chemical property. That's just what makes them the element. Okay? What gives them the chemical property is the outer shell electrons. That is what gives it its chemical property. Okay, so question 9 was C. Yes, A and D are correct in terms of what is an isotope, but not what gives it that chemical property. That's the outer shell electrons. Okay, question 10. A gas is released at point X. Okay, so the gas is going to diffuse this way. That's what it does. Okay, sorry. I'm trying to draw an arrow. Gas is going to diffuse that way. Which gas changes the color of the damp universal paper most quickly? Okay, we're looking at speed. That means the smallest. Okay, whichever is the lightest gas is going to do it the most quickly. Okay, because it's going to move the fastest. So all we have to do, which of these is the lightest? Ammonia. Okay, its relative molecular mass is 17. Okay, so your answer for number 10 was A. Number 11, the diagram shows an atom. What is the proton number and neutron number of the atom? Okay, so we have electrons. They haven't given us the protons, but they've told us that the nucleus contains 9 particles in total. You need to remember that that 9 is actually protons plus neutrons. Okay, if I have 4 electrons, there's no charge on here. Okay, they haven't shown you a charge. So if I have 4 electrons, I must have 4 protons. Okay, so we A or B. The neutron number is then going to be 5. 4 plus 5 gives me the 9 particles in my nucleus. So your answer for number 11 was A. Okay, number 12. A fruit drink colored orange contains a dissolved mixture of red and yellow coloring agents. Straight away, you should be thinking, separating colors. How do I do that? One of these coloring agents is suspected of being illegal. Which method could be used to show the presence? So all you want to do is see if this illegal coloring agent is in there. Chromatography. Okay, number 12, super simple. You're looking at coloring agents, you put it on, you separate it, and you can see, oh yes, there's the illegal agent. Okay, number 12, super nice and simple. Number 13. Right, we've got some formulae of some ions, some positive ions and some negative ions. Okay. In which row is the formula not correct? Okay. So the best way to do this is ignore the formulas on this side and write them yourselves first. Then come back and compare. So aluminium sulfate. You look for aluminium. It's Al. And it's a 3+. Sulfate is SO4 2-. You are going to swap those valencies. So this is correct. The 2 came down from the SO4 and the 3 came down from the aluminium. So you get Al2, SO4 in brackets because you can't separate it, and then you put the 3 at the bottom. Okay. I'm just checking the answer. Okay, calcium nitrate. So you look for calcium, 2+. You look for nitrate, it's just 1-. So your calcium is just going to be Ca, which is correct. And your nitrate is going to have this 2 because that came from the 2+ of the copper. So you get CaNO3 2. That is correct. Iron 3 bromide. So you look for iron 3, Fe3, and you look for Br-. That minus from the Br is going to come down to the Fe, so it's just going to be Fe1. Okay. The 3 is going to go to the Br. So this should actually be I'm not going to be able to write it. This should be Fe Br3. Okay. So you should have the Fe, and then you should have the Br, and then the 3 at the bottom, because that 3 belongs to the Fe. It came down, and the Br is just 1. So there's no 1 there. So here, C is wrong. Okay, potassium sulfide, we'll check. Sulfide, not sulfate. So sulfate is SO4. Sulfide is just the sulfur. And you're mixing it with the potassium. The 2 from the sulfur comes down to the potassium. K2S is correct. Okay, so number 13 was C. Right, number 14. Diamond and silicon 4 oxide both have giant structures. That's correct. Which statements are correct? Both substances are compounds. Now you need to remember, what is a compound? It's a mixture of elements. This is incorrect for diamond. Diamond is just carbon. Okay, so anything with 1, wrong answer. Okay. There are strong covalent bonds in diamond. That is correct. There are strong covalent bonds in diamond. Silicon 4 oxide is bonded ionically. Incorrect. It's bonded covalently as well. So anything with a 3 in it, we're going to cross out. That actually only gives us one answer, but we double check. Both substances have very high melting points. That is correct. Okay, so your answer for number 14 was C. Process of elimination. Get which statements are correct, cross out any answer that has a statement that is wrong, you get to your answer pretty quickly. Okay, silicon 4 oxide is not bonded ionically, it's bonded covalently because it has the giant structure. Okay, number 15. I've got a star next to it as well, which means quite a lot of people got it wrong. Which statement about metals is correct? Okay, layers of positive ions can slide over each other, making metals malleable. That is correct. They are positive ions and they can slide over each other, and that's what makes it malleable. Okay. Metallic bonds consist of a lattice of negative ions in a sea of delocalized electrons. That is wrong. It consists of a lattice of positive ions. Okay? Positive ions in a sea of delocalized electrons. Metallic bonding consists of positive ions, correct, in a sea of delocalized negative ions. That is wrong. It's in a sea of delocalized electrons. B and C mixed together are correct. Metals conduct electricity because positive ions are free to move. Wrong. Metals conduct electricity because negative electrons are free to move. Nothing to do with the positive ions. They cannot move. It is the electrons that move. So your answer for number 15 was A. Right, number 16. The table shows the electronic structure of 4 atoms, W, X, Y, and Z, which 2 atoms combine to form a covalent compound. Okay, so we want them to share electrons. Okay, covalent compound. I'm just checking my answer here. Okay, so basically we need our electrons to add up to 8 between the 2 that are sharing. You can cross out Z straight away because it's got a full outer shell. It's got 8 electrons in its outer shell. That means it's full. That means it's not doesn't need any more electrons. Okay, so our answer is not D because that's got Z in it. If we now look at X and Y mixing together, X has 4 electrons, so it needs another 4. Okay. Y has 7 electrons in its outer shell, not 4 electrons in its outer shell. That's not going to add up. So it's not X and Y. Just checking my answer. If we look at W and X, X needs 4 electrons. W can only give 1. It's not really going to work. Okay. If we look at W and Y, okay, W can share its 1 electron with Y to make 8. These 7 electrons can also be shared with W to make 8. W and Y can form a covalent bond. So what you're looking for in this answer is how do I make my 8 electrons in the easiest way possible? And it's when you mix W and Y together. Okay, question 17. An atom of element Q consists of 19 electrons, 19 protons, and 20 neutrons. What is Q? The easiest thing to do is look at the protons, 19. Go to your periodic table. What has 19 protons? It is strontium. And this one should not have been hard. You've got your number of protons. They've told you 19. Only strontium has 19 protons. Okay? Oh, not strontium, sorry. Potassium. Ignore that. Haha. Take that away. Okay? Potassium has 19 protons. Go to your periodic table, look it up. I'm just trying to check here. Looking at my periodic table, potassium has 19 protons. Therefore, your answer is potassium. Okay. Question 18. Lithium is in group 1 of the periodic table. Therefore, it has 1 electron in its outer shell. Nitrogen is in group 5. Therefore, it has 5 electrons in its outer shell. Lithium reacts with nitrogen to form an ionic compound. In other words, lithium is going to give its electrons to nitrogen. What happens to the electrons when the lithium atoms and nitrogen atoms form ions? Each lithium atom loses 1 electron to form an Li plus ion. That is correct. Okay. So B is also correct. Could be correct. Each lithium atom loses 1 electron to form an Li plus ion. Okay, C and D are completely wrong because it's telling me that the lithium gains an electron to form Li minus. That is wrong. It's going to lose its electron. Okay. Each nitrogen atom gains 3 electrons to form an N3 minus. This is correct. Okay. Because I've got 5 electrons in my outer shell as nitrogen, I need 3 more to make it 8. So I gain 3 electrons to form N3 minus. Okay, your answer is not B. You don't gain 5 electrons. 5 plus 5, 5 that it already has, plus another 5 makes 10 electrons. I don't have 10 electrons in my outer shell. I have 8. So I've got 5 electrons. I need another 3 to make it up to 8. So your answer for number 18 is A. Okay, number 19. 2 acids, W and X. The same volumes of W and X are reacted separately with excess magnesium. The student makes the following observations. Hydrogen gas is produced at a faster rate with W than with X. In other words, W had a lot more bubbles than X, a lot faster. The total volume of hydrogen gas produced is the same for both acids. That is because they tell you here the same volumes of W and X were reacted. So if you've got the same volume of acid, you will have the same volume of hydrogen produced. What's important here is that it was produced faster with W than with X. That means that W is stronger, a stronger acid, because the hydrogen was produced at a faster rate. So it is a stronger acid. Okay, so stronger acid, that's the first thing you need to figure out. Okay, so the pH of W is higher than the pH of X. That is wrong. A lower pH means that you are stronger. W is an organic acid. There is no way to tell that. Okay. W is stronger than X. That is correct. If W is more concentrated than X, that might not change the speed of the bubbles. It's the fact that W is a stronger acid. Okay. So therefore, it is going to produce hydrogen gas faster. So your answer for number 19 was C. Okay. Number 20. The graph shows how the pH of a soil in a field changed over time. At which point was the soil neutral? pH of 7 is neutral. Your answer should have been B. You all should have got number 20 right. That was nice and simple. Okay, number 21. When sodium chloride is formed from its elements. Okay, so what are the elements of sodium chloride? They are sodium and they are chlorine. Each chlorine atom, so now you need to think, okay, chlorine, how many electrons does it have in its outer shell? It's got 7 electrons. So therefore, each chlorine atom, how do I get 8? It gains, so my answer is either A or B, 1 electron. Okay, so number 21, your answer is A. Chlorine atom will gain an electron to become with 8 electrons in its outer shell. Okay, question 22. Which statements are properties of an acid? They react with ammonium sulfate to form ammonia. Wrong. Bases. This is just something you have to learn. Bases react with an ammonium sulfate. So number 1 is wrong. So your answer is C or D. Okay. They turn red litmus blue. Wrong. They turn blue litmus red. An acid turns blue litmus red. Your answer is D. Okay, almost there. Question 23. Which element forms an acidic oxide? Metals form basic oxides. A is hydrogen. Hydrogen oxide is water. That's neutral. C, if you were to draw your step over here, you would see that C is on the left. That means C is also a metal. So your answer is D. D will form an acidic oxide. It is a non-metal. It's on the non-metal side, therefore it forms an acidic oxide. Question 24. What is the correct sequence of steps for the preparation of a pure sample of copper 2 sulfate crystals from copper 2 oxide and sulfuric acid? This is the exact practical we did. And if you can't remember the steps, then you need to pay more attention in class. So all of them start with dissolving. Okay? Crystallization, that happens at the end. Okay? Evaporation, no. We have to filter something off first. So we're now looking at C or D. Filtration, so you dissolve it, you filter it, you then evaporate it, you then crystallize it. Okay? So 24, your answer was also D. Okay? Crystallization comes at the end. You have to filter it first because you have to get that copper 2 oxide out, filter it, evaporate it, crystallize it. Okay. Okay, last question. Which relative molecular mass is not correct for the molecule given? You had to use your periodic table here and you had to work out the MR. So ammonia, what is the MR of nitrogen? What is the MR of hydrogen? Does it add up to 17? Hydrogen times by 3. Okay. Carbon dioxide. What is carbon? What is oxygen times 2? Does it add up to 44? You will find that it does. Methane. Carbon plus 4 oxygens does add up to 16. Oxygen is O2. So the MR of oxygen when it's O2 is actually 32, not 16. 16 is just one oxygen atom. Okay, we have 2 of them, O2. So you would have 32 here. Okay, so that is your multiple choice. I'm going to stop there and I will do another video for your long questions. Okay, so go through this video, focus on each question that you know you got wrong, and make sure that you get it right. Okay, thanks guys.